Okay, I guess we'll go ahead and get started. So today we have Python, and then we're going to have micro lectures on Bash and Git. Okay, so a few announcements. Well, actually, before we do announcements, let's go ahead and do attendance. So go on Relate and just complete this short quiz, and we'll go ahead and do it with you up here. Okay, so if most of you guys are done, we can go ahead and continue. Let's see. Okay, so office hours, as usual, will be 7 to 8 p.m. tomorrow and Thursday. You can check the calendar to see who's going to be there. But yeah, if you have any questions, I know there were a lot of questions on the homework this week, so if you have those types of questions, you can definitely go to office hours and ask. The homeworks are going to get a little bit more difficult as we go on, so you definitely want to take advantage of these resources. Okay, so the hackathon this Saturday was kind of the launch for you guys' projects. So we talked about joining the Slack. So if you haven't joined the Slack yet, please do so. This is the URL. Yeah, and so basically join this and then join the specific channel that has to do with your project. That's where all of your project communication is going to go on. So does anybody have any questions about Slack or about any of this? Okay. And then basically, your first project meeting should be this week. So your PM should have scheduled a project meeting with you sometime before end of day Sunday. So if you haven't reached out, if you haven't had any communication with your PM, you need to come talk to me. Basically, if you didn't show up to the hackathon, they should have sent you an email inviting you to the Slack channel and basically getting you set up with what's going on for this week. So if that hasn't happened, please come talk to us after lecture. If you don't have a group at all, please come talk to us after lecture so we can get you set up. Okay, so basically, what's going to happen this semester is you're going to be graded on a weekly basis. So a portion of the project grade is going to be split up between your attendance, your contribution, and your code quality each week. So instead of evaluating all these components at the end, like we've done in the past, we're going to evaluate you on a weekly basis and then post these grades on Relate. So every week your PM is going to grade you, and then you'll be able to see how you're doing. So if you're not doing so well, you can improve. If you feel like your score isn't fair, you can go ahead and ask why you got that. So basically, attendance is straightforward, showing up to the meetings. You have to remember this is a class, so if you don't show up to a meeting, you have to have a legitimate reason, like an exam or illness or something like that. It can't be, last semester we had a kid who always went to Walmart during his group meetings, so that's not a legitimate excuse. But basically, yeah, anything that's like in the student code for missing a class applies to this. And then the second thing is contribution. So how much did you actually do with the project? In the past, there have been a few groups where it's been very unbalanced, like one person did most of the work and then another person kind of did nothing. So each week, you guys are going to talk about like what you did, and this ensures that you guys will actually contribute equally. And then the last thing is just code quality. Are you writing nice, clean code? Are you following good Git procedures? And we'll talk about Git today. That's one of the micro lectures. So basically, this just makes it so that at the end of the semester, everything is very clear. You guys know exactly why you got the grade you got, and everything is very transparent. Okay, the last kind of announcement is we've had a few issues with people finding old resources online. So basically, everything you need should be on the course website or it's on Relate. You shouldn't be Googling for anything. We've had a couple of people do old homeworks, and the old homeworks are harder. So I mean, props to them for like actually doing them, but like basically just do the homework that we've actually assigned. So yeah, don't go looking for other stuff. Okay, and if you have any questions, just email me or Vivek. And that's pretty much it in terms of announcements. Okay, so just give me a sec. So actually, before we get started on Python, I do have one question for you. It should have been in the announcements, but I forgot about it. So basically, I wanted your feedback on the hackathon. So we have like a ton of candy over here. Anyone who gives me some sort of feedback, criticism, or something you liked, something about the food, anything, you can come up and grab a piece of candy. But we want to know because like in the future we're gonna have another one. So yeah.
The food was delicious, but it was early.
The food was early or the hackathon? Okay, that's a valid concern. You can go get one if you want. Yes. Anybody else? Yeah.
My group had no PM.
Oh, okay, yeah. That's pretty sad. That does happen occasionally. But yeah, that's just kind of unfortunate. Anything else? Any other comments? So it's too early, but the food was good. What kind of food would you guys like next time?
Pizza.
Pizza?
Yeah, more replenishing.
More?
They were kind of like calzones, except not calzones, like shredded stuff.
Okay, I found them very filling. I thought they were good.
Really?
Yeah.
Okay, might be.
Yeah.
Can I still get candy?
Hmm?
Can I still get candy?
Yeah. But yeah, okay, so it seems like you guys enjoyed it overall. It was just kind of to give you an introduction to your team, so yeah. Okay, so now we can actually get started on Python. So last week we talked about lists, and it was pretty straightforward. This week we're going to be talking about 2D arrays. So, basically, does anybody want to give me like an example use for a 2D array? Yeah.
So like area, length, like width.
Mm-hmm. Okay, so to represent something that has a width and a height, right?
Yeah, literally like 1, 2, 3 dimensions.
Mm-hmm. Or like a three-dimensional thing too, yeah. So we can have multi-dimensional lists, and then with like a two-dimensional list, yeah, we could represent something like an image, right, that has a width and a height, where we might want to access each pixel, right? Does anybody have any other examples? Okay. Okay, so this is our first example here. So we just have a list of lists. So basically, X is our list, and it contains 3 sublists here. Okay, so does everybody understand the structure, like how this works? So this is how you would declare, this is one way of declaring like a 2D list. Okay. Okay, so basically, okay. So basically, what do you think we're gonna get if we just print X? We're just, oh shoot, not that. Okay, so we're just gonna get the list, right? That's pretty straightforward, but what about if we try to access the 0th index? What should we get? How about somebody who's not answered before? Somebody on that side. Yeah.
The first array.
The first array, yeah, right? So when we do this, yeah, we get that first list, right? Okay. So what's going to happen if we do something like this? Yeah.
Prints 1.
Prints 1? Exactly, right? So can somebody explain why it prints 1? Yeah.
It's the first element of the first array, or like first set.
Yeah, so if you look here, what we're basically doing is we're getting the 0th element of the list, right? So that would be this. And then we're going to get the 0th element of that sublist, which is this. Yeah, so good job. That's exactly what's happening. Okay, so basically, that's pretty nice, but our array was like pretty small, right? So you can imagine, like in industry and stuff, in different applications, arrays will be giant, right? Maybe they're going to have thousands and thousands of entries. So if I want to actually populate an array without having to go in and put every single number by hand, I can do something like this. So what do you think a function like this actually does? How about somebody in the back row over there? Anybody? What about you sitting in the very, very back row? What do you think this code does? Okay, so she's saying that basically it creates an array, it creates like a 2D array, but there's nothing.
No. It creates the one that we just created, 1, 2, 3, 4, 5, 6.
Yeah, exactly. Okay, so basically what this is doing, if we take a look, so we've got a count variable, we've got an empty list, and then so basically we go through. Because we're recreating this list, right? So we're going to go through our 3 groups, our 3 sublists, and then we're going to make those sublists. So we're going to go through 3 times, make 3 sublists, and then for each of those lists, we're going to go through and append a number, right? So every time we append a number, we append a count, and then we increment a count, right? So when we actually run this, we get something like that, right? Which is exactly what we did before. So does this make sense to everybody? Does anybody have any questions? Okay. Okay, so basically, lists kind of, or 2D lists kind of work like other lists. So if I have this one here, shopping list, so I have a bunch of stuff, right? And then let's say I want to add something, right? So I have this new sublist, and then I'm just going to use append, and then what do you think that's going to look like? It's just going to be added to the bottom, right? So, yep. So now our list looks like this. Okay. So basically, before we get to the next part, how do you think we would be able to figure out the dimensions of a list? So if I say, or a 2D list, if I give you a 2D array and I say, okay, I really want to know the width and the height of this array, right? How would I actually go about doing that? Yeah, back there.
You iterate through the upper or further away, like level of it, so each smaller array then gets iterated through also, and you have a variable called sum, and you just add for every.
Okay, so that's a legitimate way of doing it, but is that the easiest way to do it? Is there an easier way in Python to just get those dimensions? Anybody else? Because you guys kind of learned it last week, but you learned it with 1D list. Yeah.
Maybe you could do length or the LEN.
Yeah, that's a great idea. So basically, if we look here, this is going back to our array x, which was this one. But basically, if we print length x, if we get the length of x, and we get the length of the first element in x, right, which is going to be that first list, we can get the dimensions, right? So if I run this, we're going to get 3 rows and 3 columns, right? Does that make sense? Does anybody have any questions about that? Because that can be a little bit confusing. Okay. Okay, so basically, the last thing we're going to talk about with multidimensional arrays is the fact that in Python, you don't have to have an even number of things in each sublist. So basically, if you look at this example, we've got 3 things in this list, 2, 1, and 3, right? Just kind of weird looking. Yeah, back there.
For the one above,
Uh-huh.
in your print statement, why did you turn the rows into strings?
Because length is going to return an int, right? So we can't just print that. Like, we want to convert it to a string first. We're casting it as a string first. Yeah, we talked about that last lecture too. So yeah, if you want to print this, it's easiest to just cast it as a string first. Okay, so back to jagged lists. So this may seem a little bit weird, but it's also pretty straightforward like the other list stuff. So does anybody know what jagged x of 3 would return? So let's see, where would that put us? So 3, 0, 1, 2, 3, right? So 7, 8, 9, right? We're going to get that sublist. And let's see. Right, that's what we get. So it works just like the other 2-dimensional list. If we do this, what do you think we're going to get? Does anybody want to guess? Okay. Oh, shoot. We're not going to get anything because it's a syntax error. Hold on just a sec. All right. What do you think we're going to get if we run this? Yeah.
8?
Yep, and that's what you get, right? So it makes total sense. It's just applying what you learned before to this new example, and it's pretty straightforward. So, yeah. Okay, so does anybody have any questions about lists in general, multidimensional lists, how we can access them, what we can do with them, anything? Any questions? All right, okay. Okay, so basically, just to kind of wrap this up, since we're talking about arrays, we're kind of getting into stuff about runtime, big O notation. So if you guys are in like 125 or 126, you've probably heard about this. If not, that's okay, because we're going to cover it. So basically, big O is just talking about how efficient our solutions are. So we can have a problem, and we can have one person solve it, and they have a correct solution, and we have another person solve it, and they also have a correct solution. but one runs much, much faster, one's much more efficient, right? So there's a lot of ways, like when you guys are doing the problems that we give you, there are ways to do them really inefficiently, and we want to teach you guys how to write more efficient code, right? So basically, let's talk about how much time it takes to like sum up elements in a list, right? So let's say we have 5 elements in a list, right? That's going to take a certain amount of time, right? Actually, so we usually do this with variables, right? So let's say we have n elements in our list, right? How long is it going to take if we have 2 n elements in our list? How long should it take? Let's say the first one takes 5 seconds to go through n elements. How long is it going to take if we double the amount of elements? 10, right? Yeah, and so there's a linear relationship there, right? So we call that O of n.
Isn't that supposed to be O1?
No, okay, so the difference is, so O of 1 is constant time. So O of 1 would be if I said, okay, here's a list, give me the element at the 7th index of the list.
Oh.
Because that's just constant time, it just goes and does it, right? It doesn't depend on how many elements there are. Okay. Yeah, so you can kind of see, there's different examples here. So if you have a 2D list, right? How long, so if we have n elements, right? How long is it going to take if we want to go through? Okay, so let's say we have a 2D list, right? And we have, sorry, this is a better explanation. Okay, yeah, so if you have an n by m array, and you want to go through every single one of those elements, what is the runtime going to be? Mn, but we also call that like, it's basically n squared, right? Okay, so basically what's going to happen is it's going to increase faster, right? The more elements we have, it increases exponentially instead of linearly, right? So if I have my one-dimensional list and it has some stuff in it, and I increase it, the time increases linearly. But if I have a multi-dimensional list, and then suddenly I want to go through every element, it's increasing exponentially, right? Okay, does anybody have any questions about that? Okay. Okay, yeah, and this, we basically already covered this. If you have an n by n matrix, in order to like, if you wanted to sum everything, you basically have to go through every element, right? So the runtime depends on how many elements there are. So, okay, does anybody have any questions about this? This is just some like really basic runtime stuff. Like it gets a lot more complex, but this is kind of just like the fundamentals. Yeah. Okay, any questions? No? Okay, so if you guys don't have any more questions, we're going to move on to our micro lectures. So our first one is Bash. Yeah. No, wait, you shouldn't have it. Yeah, it works.
Sorry, I needed a bit of time to set this up. All right. geez, that's real small. Or maybe it's real big. The windows and stuff. Alright, can everyone read this? No, because it just disappeared. There. Can you guys read this? Like all the text on here?
It's a little hard to read
On the right. How about now? Alright, I guess we're doing this lecture in the dark. Alright, so you guys can follow along with this thing I wrote at this URL. I'll paste it in here. Yeah, question?
When you like use a normal mic, it's like really annoying, it's static.
Is that better?
Yeah.
Good, it wasn't my mic. Alright, does everyone who want to look at this page have it open? So, yeah. Take that as a yes. So I guess to get started, how many people here have like Macs? I'd say like half the room has some kind of like a Mac computer. How many people have like a Windows computer? Well, that's a large number. How many people use Linux? All right, there's like 3, 4, 5. Oh, that's not bad. That's not bad. All right. This will be relevant later. We'll talk a bit more about this. But first of all, what is going on? I think I just keep bumping like the HDMI cable or something. That's fine. So I'm here to talk about Bash. And I guess first things first, what is Bash exactly? So Bash is a shell. So then we must explain what a shell is. So what is a shell? So according to Wikipedia, the definition of a shell is a user interface that allows you access to an operating system. So there are, like command line shells like Bash, and there's also, like user interface shells, which we won't talk about because command line is all you need ever. So what Bash actually stands for is the Bourne Again shell, and the reason why it's that is because there's actually a shell that came before it called the Bourne shell that just wasn't very good. I can show you guys what that looked like too. And then besides Bash, there's a bunch of other shells out there like Zeesh or Fish. Probably can't read that. I would personally recommend you guys use Zeesh. I would not recommend you use Fish. Bash is like not bad, but it's also just not good. It's like very, in the middle. It's very mediocre, I would say. It's very, it's usable. But if you wanted to, customize your command line and have it look really pretty, I would recommend using Zeesh. So then, what exactly do you need to like start using like a command line interface on your computer, right? So if you're on Linux, just open up your terminal. Sorry. If you're on Mac, also open up your terminal. But if you want a better one, I would install iTerm 2. There's a link here, and also you're gonna need to install Homebrew for package management, which I'll talk about later. So both of these links are again in this website, which I don't know. It's on my GitHub. And then for Windows, you could use Bash for Windows 10. It's a thing now. It's not very, I guess it works and it's functional, but developing in Windows is just pretty strange, honestly. Like, there's a lot of things that can run in the way. So I would definitely recommend you get some kind of Linux flavor, either in like VMware or as like dual boot. And if you guys want help with that or anything, like talk to me afterwards. I can like point you in the right direction. I highly recommend developing in Linux if you guys are gonna do like any like serious kind of development work. There are some like, I guess in Windows you have like a bunch of IDEs that work well for specific languages, but in general you want to use Linux. Or get a Mac, but that's really expensive, so it's not really an option for a lot of people. Alright, so I talked a lot about like, it's this command line interface. So how exactly do you use it, right? So the shell basically does everything you would use like a GUI to do. So for example, coming back to the house computer, how many of you guys like do things with the file manager? Like on your Mac or on like Windows, like this thing right here. This is audience interaction. I don't really believe that like 3 of you use this because I'm pretty sure most people do. Are you guys like paying attention? But like, wait, so how many people like have used this in the past? Excellent. That should be like every single one of you, because I'd be pretty confused if it wasn't. So you guys know, like, you can browse sort of through your files or whatever. Let's not look at that actually. And you can like, look at your folders, go into folders, go out of folders, make new files, open files, read files, look at metadata about files, etc., etc., etc. But you can actually do all of that from the command line. So going back to my computer, I actually don't even have like a graphical like file manager installed, so I can't demo it on my computer at all. But I guess the first things are the most basic commands that like everyone uses constantly, at least 2, cd and ls. So if I ls, you can see I just listed like, yes.
Is this web page included in the, included later on CS 196 website?
I can post it on Piazza.
Alright, you wanna do that?
Yeah. Say again. Alright, so back to the first 2 things that you should always like do constantly is ls and cd, do like change directories. So right now I'm in something what's called my home directory on my computer, and you can see I have like some folders in here. I have some books, I have downloads, I have pictures, I have my school stuff. If I wanted to go into a folder, and this is like the same thing as double clicking on a folder in Windows or on your Finder on Mac and just like going into a folder, I type in cd and then the folder name. So for example, if I want to go to demo, I type in demo, and now I'm in this folder called demo. You can see the contents of the folder have changed. If I want to go back to like my home directory, I just type in cd ... and what dot means is just go back, or go out of folder, rather. So I told you I would show you the other shells that exist. So here's the bourne shell, the regular shell. Sorry, right now you can see this is what it looks like. It doesn't really give you much information. It just tells you it's the bourne shell, version 4.4, right? So say like I can say ls. There's no nice coloring here, I guess. Just do that. If I go into the demo folder again, you notice that like nothing really has changed out here. Like it doesn't really give you any information, right? So this is like something Bash avoids and also like Zeesh avoids. This kind of confusion about where you are. So in order to like find out where you are in general, you type in this command pwd, which stands for print working directory. But since you don't want to like print working directory every single time you like switch directories to like figure out where you are, that's why like modern shells like Bash or Zeesh will just like straight up tell you where you are. So for example, if I exit out of this shell and then go to demo, you can see that I have it set up so that like my the directory I'm in is just like right here. And also if I go into Bash, you can see that Bash lists me as inside my demo folder right now. If I go back out, you can see that this tilde means that I am currently home. The tilde means home, by the way. So now you can like sort of move around your file system. Actually, first, any questions before we go further? Okay, so in order to actually do stuff, like we want to do like our mouse in a Windows file system where we can like right click, make new folders, make new files, etc., etc. There's a bunch of commands that also just do the same thing there, right? So let's go back to our demo folder. This is in Bash because that's what I'm supposed to be teaching. So if I want to make a directory, I type in the command make directory, or mkdir, and then the directory name. So for example, let's make one called test. Now if I ls to list everything, you can see that now there's a directory in here called test, and I can go into it. So now if I like pwd, you can see that I'm in my home folder, demo, test, right? So then if I wanted to make a file, there's a command called touch. So if I touch, test file. And now if I type in ls to list everything in the directory, you can see that I've just made a file called test file. And like there's probably nothing in it because it's just a random file. But we can confirm there's nothing in it using this command, cat, which stands for concatenate. So concatenate will actually just like tell you what's in your file. So for example, if I cat test file, you can see there's nothing because it just like printed an empty line. Let me show you this on a file that's not empty though. So if I cat my hello.java program, you can see that there is in fact a hello world program in this hello.java file I have. Just clear the screen. And then say I just wanted to like, type something in. So let's go back to the folder where I made a new file. So say I wanted to fill my test file with like some random junk. There's you use a text editor. This is a command line text editor called Nano. So I'll go into my file I made. And if I type some stuff into it, like just some random keyboard mashing, I save the file, enter, and now if I want to like cat the file, you can see that there is stuff in the file. And there's a lot of other text editors out there besides just Nano. Nano should be included on like basically every system though, so it's pretty constant, right? There's a lot of other things that you may have to like install if you want to use Atom, for example, or Sublime Text, or any of the other text editors that you're familiar with right now. But yeah, are there any questions on these 4 commands here? No? Okay, let's keep going. So you can Control C, Control V in your graphical like Finder window, but here you have to do some other things, right? You gotta, if you want to copy a file. So let's say I'll make a copy of my test file. So I'll copy the test file, and I want to copy into, I want to move it outside of this test folder into like the previous folder I was in. So pwd, I write down my test file. I want to copy my test file into the demo folder. And how I would do this is I type in copy, the file name, and then the location, which in this case would be ... because ... always refers to one directory outwards. So now if I go outside, there's a test file inside the demo directory that I made. Right. And you can do the same thing with move, except for, if I moved the test file from this directory to my home directory. So if I move test file ... like basically the same thing I just did, except instead of copying, I'm moving. Now you'll see that the file is gone, and it has in fact moved. If I leave and look, it has in fact moved outside into my home directory right here. So then, I don't really want this test file though, because it's just a bunch of garbage, so I'm just going to remove it using the rm command. So now it's gone. Let's go back into demo. And let's copy the test file again back here. So I have this test file, right? And another thing move can be used for is actually renaming. So there's no like rename command for file. Instead, you just move the file in place. So I would say move test file to, what's a better name? Like ADSF file, because that's what it's. So now you can see that all I did was just rename this file. If I cat the contents, it's still all just the same. And say you want to or actually, sorry, any questions at this point for like basic file manipulation using your command line?
So
Yes.
using that move test file, ATSD file, can you create a different name?
Yep, all I did was rename the file.
Or you use the move command?
Yeah. So there's no rename command. Instead, you would just move a file in place to rename it. Yes. Any other questions?
So when you use MV, you can only move it once, or can you is it like copy and paste? It's sort of like cut, and
Yeah, exactly. It's just like
then
that.
can you put it to multiple places or just one place?
Only one place. because it takes two arguments, right? Or it takes file and a destination. Although maybe there's an option to move things multiple places. I don't know if like I've ever needed to do that. But in case we wanted to like find out more about the move command, there's this other command called man, which stands for manual page. So if I say man mv, I get a bunch of information about move. So you can see here's a bunch of flags. We'll talk about flags in a sec. Basically, like if you type in man in any command, for example, I just did man nv, right? So if I type in man like ls or man cd, you'll see there's a lot of like, it gives you a lot of like, information about what the commands actually do, just in case you forget. And this is pretty cool because like I forget a lot of things, so I just man constantly. Okay. Are there any questions before we talk about flags? Okay, so these commands I just taught you, like everything up here, also can do slightly different things if you give it a different flag, right? So what flags are just like options that you can also pass into a command to make them like, do more or do other things, right? So for example, one that like one that I use a lot is ls-a, which stands for list all. So if I ls here, sorry, let's go back one. If I ls here, you can see my home directory, I have like, 9 folders. But now if I type in ls-a, you can see that there is actually a lot of stuff in my home directory, right? And all these like folders and stuff with the dot in front of it are called hidden files. And like you should have, there should be hidden files in like, Windows and Mac, and like, this shouldn't be like, an unfamiliar concept of like being able to see hidden files. But you can see like, I have a lot of like config files in here, and like the actual size, well, the actual like contents of my home directory is actually a lot bigger than just ls would see. So again, the flag ls-a will list everything, including hidden files. Another flag that ls has is -l, which gives you more detailed information. So if I dash ls-l, you can see that here I have the same 9 folders, but here like they tell me that these are directories, they tell me the permissions, you don't have to worry about this stuff. It tells you who owns the files, like, how big they are, when they were last modified, etc., etc. So it gives you a lot of like extraneous information about the contents of your directory. And then now here you can see that, yes, you can combine flags. So if I type in ls-la, this is probably like, you probably can't see anything here, it's like really small, so let me just, this way it'll show you all the files I have in the long form. So are there any questions about flags before I talk about like anything else? Does passing extra options into like commands make sense? Very good. Okay, so let's go back in the demo. The last like flag that I use a lot is rm-r, which stands for it stands for remove recursively. So if I try to rm my test folder, it tells me I can't do that because it's a directory. And I think there is a command like rmdir, like that removes directories, but instead you can type rm-r, which is recursively remove test, and now it's gone. Because basically what rm-r does is it'll remove everything inside the folder and then the folder itself, including subfolders inside the folders. And then this last command we'll get to later. Any questions about flags or these commands or anything, honestly? Like life. Yeah.
How did you learn so much about this?
I was born with this knowledge. Any other questions?
Need talk a little bit about the food.
Sorry.
The food before, like, what does the food do for the magic?
perfect segue into this section. First, are there any other questions? Yeah.
What am I gonna use this for?
What are you gonna use this for? Well,
To me, it just seems like you could do any of this just by like clicking on like the buttons in the GUI that you had shown previously.
well, let's talk about that at the very end. How about?
Okay.
All right, I will attempt to convey my passion about command line at the very end after you guys have a little bit more background information, which is the rest of the stuff. So let's talk about package management first. So like when you're on Windows or on your Mac and you want to install. Sorry, well, there's another question. Did I miss any hands? Just like yell at me if I do. But back to package management. So like, on Windows or like Mac, when you want to install something, you'll install like where you like download like a DMG or like an MSI file, and then like you'll double click on it, and it'll give you like nice progress bars and whatever. Right? Yes? No? I see some nods. Okay, I'm just gonna keep going. You can also do that kind of thing, but with your command line, and instead of like downloading like application on a window, I guess you'll be downloading command line tools and like libraries and stuff. Because like there's a lot of tools that don't come bundled with just like basic command line stuff that you'll have to install yourself. For example, Python. And how you do this is if you have a Mac, we'll go back up to the Homebrew that I was talking about. Homebrew is a package manager that lets you download stuff, and it's real nice. If you have any Debian-based Linux system, like Debian, Ubuntu, probably I think Windows Bash is also counted in this. You'll be using a package manager called apt, which I think it stands for Advanced Packaging Tool. I don't really remember, but let's just get to an example actually. So if you wanted to install, for example, Python on Mac, I think you would just say brew install Python 3. That's the type of Python you want to install. You don't want to install Python 2. For apt, it would look like sudo apt get install Python 3. Yes?
What are the instances that we need to use sudo?
So, okay. That is also a very good question. Let's talk about sudo for a second. So you guys are aware of like sort of privileges on your computer. For example, like Windows administrator, or like on Linux, your root. I guess Linux and Mac, you have like a root user that has like access to everything on your computer versus just like regular stuff. In general, if you want to do things that modify like your root files, like for example, if I go to the very root of my machine, you can see there's some like very scary looking folders here. And like when you install stuff goes into /bin actually. You don't have to remember this. I'm just like going on a tangent. So you can see like here, I have like probably thousands of like commands or something. So this is where all your installed stuff goes if you have like a Unix-based machine. Let's go home. That's too much. So if you wanted like perform any interaction that would require root access or administrator access to your computer, like installing a package into like your bin, then you would need to sudo, which stands for super user do. And that basically asks you to like type in your password and like confirm that what if like someone comes in and was like, hey, I want to remove all the files in your computer, right? Then sudo would, but then like your computer would be like, no, you have to have like sudo permission to do that. So that's when you'd use sudo. So in general, also whenever you like type in a command and you see an error like you need permission to do this, then you just put sudo in front of it. Oh my gosh. How distant. Okay, we're back. So actually, you may have to sudo brew. I don't remember because I don't own a Mac. Jeez. Everything's broken. And you get a better computer. Okay. So hopefully that doesn't happen again. Back to the stuff. So if you guys want, try installing like Python or whatever. You'll probably need it if you wanted to do homework assignments or just program in Python on your computer through your command line. If it doesn't work, tell me, and then I'll Google for an answer. That's what you do if you don't know how to do things. But once you have Python installed, this is just some this is like, you know, just like the tip of the iceberg, honestly. Like, there's so many more things you can do, but I just want to focus on Python and Java because this class you'll use Python, and then if you're in 125, like, you'll probably do Java, and you're probably used to using Java through like an IDE, like Eclipse or IntelliJ. So I just wanted to show you that you can also, like, you know, do all this stuff through your command line as well. So let's see, let's put it in my demo folder again. Here I have the two programs from before. So first, I want to check my Python version, just to make sure, you know, I'm on Python 3. Python 2 is very silly. You guys should use Python 3 for sure. So let's say Python hello.py, and it just says hello, which is what it's supposed to do. It's not like a bug or anything. So this is all that's in the Python file. And then also, if you wanted to run like an interactive Python shell, so this is what's called the Python REPL. So now I'm inside like the Python program, and every time I type something in, like if I type 1 + 1, it'll give me 2. Because what will happen is I input, Python will evaluate whatever expression I give it, and then give back an output. So I can say like, you know, print hello. I can say like for like I in range 10, print I, and I'll do that, you know. So this is like a very useful tool for debugging Python programs, where you can just sort of type in commands and see like what is working and what is not. And then also to show off Java, first you need to compile the Java code. So I have a hello.java file here. So I compile it with Java C, which stands for Java compile, hello.java. And now now if you look, you can see it generated a hello.class file. So now if I type in Java hello, hello.java, you can see it just prints hello class. And then you'll also probably have to install Java too. Or not Java 2 as in Java like version number 2, Java 8 is I think the one you guys want. I'm trying to make some jokes here. So does installing packages to your command line make sense to you guys? Alright. In that case, alright, this is back to my regular stuff. So, also, if you haven't noticed, clears your screen. It's really nice. I sort of just like spam clear whenever I don't have anything to type. So this is my package manager. It's called Yawert. You guys won't have to ever deal with this. Don't worry. I want to install. Let me install this package. It's called Cowsay. So if you wanted to do this on Mac, you would say brew install Cowsay. If you want to do this on, you know, if you with apt, you just say, you know, sudo apt-get install Cowsay. So now I have this program called Cowsay, and what it does is it makes a nice cow. Right. So I don't really know what this does honestly. So I'm gonna go and man. Oh, I don't want to do that. I'm gonna go man Cowsay. And you can see here, I have a lot of information about Cowsay generating pictures of cows. Right. So I also want to get this other program called, well, first I need to search for it. It's called Fortune. So it's called, the package name is Fortune. And then, again, I don't have a Mac, so I can't really say how you would search things on Brew. But for Aptitude, or apt, you can do apt-cache search for a package name in order to find packages. So now I have this other program. It's called Fortune. and all it does is give me like fortune cookie fortunes. You know, like. Or actually, these look like inspirational quotes actually. They're supposed to be like fortune cookie fortunes, you know. So that's an example of package management, by the way. I just installed some packages. Yeah.
Well, how would you use like tab to like quickly print out the stuff?
Oh, good point. I totally forgot to mention that. Okay, so you guys were just saved years of pain because I almost forgot to teach you guys how to tab complete things. So you may think, let me show you like a very long thing. So you see here, I have like these really long folder names, and you might be like, hey, like, do you have to type every single character in that folder name in order to go into that folder? And the answer is no. So shells these days have a thing called tab completion, where if I say cd, CS196, this is autocomplete. This isn't what I'm talking about. Don't worry about it though. Let's go bash. So let's go to cd CS196 dash. So if I type in like F, I press tab, it'll complete the whole thing. So I don't have to type like all of it, right? And this is like super useful. And I can't believe I forgot to mention it. Yeah.
What is the thing that you used before the bash? Is that a different? Is that Zish?
Yeah. So if I go back to Zish, I have my Zish set up so it auto completes things. So if I say cd CS196 FA, so like
It shows the.
it gives like auto completion options, and this is like the kind of thing you can set up if you have like Zish, or I guess you can probably set up on Bash, but it'll be harder. But you can also like customize with nice colors and nice themes and all these like cool things. Yes.
Oh yeah, and how do you customize the color?
There are a bunch of ways. If you guys are interested in like making your stuff look super nice, talk to me after class, and I can help you with that. But anyways, yeah, tab complete like a bunch of things. Your tab complete like will save your life and it'll save you a lot of time. And it's one of the reasons I think like browsing on your command line is much faster than using like a file manager or a file browser, because like you have to go around and you have to click and you have to move your mouse, and that takes time. But if you like just type super fast and you like tab complete everything, you can like navigate your computer so much faster than like using a GUI of some kind. Any other questions about tab completion or any of that stuff?
Oh, did we
Yes.
talk about flag yet?
Yes. We talked about flags. It's up here.
Oh, that's.
Yeah, those are flags.
So what is the payout?
You guys can find that out by yourself. If you guys are interested in what this does, you guys can install a package and read the man page. I might show it off anyways. I don't have the package, so I'll have to get it. But let's go back to the advanced stuff I was about to talk about with Fortune. If you remember Fortune, and also Calce. So as you guys know, like, or as you guys might like have started to figure out, there's a thing called standard out, where programs will print to like your standard output. Like for example, if you type in like print in a Python code, it'll like print whatever it is to the standard output, which is basically just like whatever your terminal wants to display, right? So there's a way of putting standard output into the standard input of another program. So if that's called pipe, which is this character. It's like the long straight line thing. So if you want to say, I want to put the output of Fortune into the input of Calce. So now I have a cal that gives me Fortune, which is I think the pinnacle of technology. Like look at that. I don't know what like any of these mean. There's other things that you can do with the terminal too. One other thing that's like very common is file. So instead of piping is like program input indirection. So you put standard out and standard in, but you can also like put files into a program using this character, like an arrow, which makes sense honestly. So if I go, let's go back to the demo real fast. and then I promise I'll be done. Let's see. So I want to say like house A. Let's put a Python file in here. So you can see if you want to like redirect a file into a program, you use this thing. If you want to redirect a program into a program, you use the pipe character. And this is real nice for stuff like, for example, when you saw me, when I was looking for the right fortune, program, I piped my thing into less, which basically makes it a scrollable thing, so I can like actually look at all of it. Instead of, if I say like this, then it just sort of scrolls all the way down. I have to like, you know, I have to like go all the way to the top to like find it, and it's really annoying. So there's a lot of like neat little tricks you can do with your terminal involving piping or redirecting like input and output. And again, if you're interested in like any of this stuff, come talk to me afterwards. I'll show you some other things. All right, any questions? You're good? Oh, also the last thing, why you should use command line over like clicking through a GUI. Honestly, GUIs are slow. Having to use your mouse is like really slow, and like it gets in the way of typing out your programs. And I think like it breaks my train of thought when I have to like go to my mouse and like click on somewhere and also like go back to the But basically, there's a lot of command line tools to enable your development. For example, what I'll do when I develop Python is I'll have Python open, like I'll have a text editor open on the side, and I'll have like, my command line on the other side. So I like make a change, I'll save, I'll go to my command line, I'll type in Python, run the program, see the output, and immediately go back and like keep editing. Right? And you can sort of do this in like a GUI, but I think like, if you have to, so if you use an IDE, right, you can press like the run button, and then, your program will run, and everything will be good. But you'll have to get a new IDE for basically every single language you want to do this for. But command line is like sort of the standard for everything else. So if I wanted to write a Python program, Java program, C program, Go program, literally any language works in command line. And I don't have to like track down anything else. Does that make sense? Also, it's just faster. And it makes you look cool. But only to like people like me.
Alright guys, my name is Shreyas, and I'll be talking to you guys about Bash. Victor will talk to you guys about Bash. I'll be talking about Git today. So Git is a version control system, and basically what this means is it's basically like Google Docs for your code. So you guys are going to be working in groups this semester for your project, and you're going to have lots of people in your group working on different features of your product. So it's important to make sure that everyone's work streams are clear and that you guys can merge your changes efficiently and without any problems. If, say, I'm working on a feature and my partner is also working on the same feature and we both have like conflicting files, that can be a big problem. We don't want that to happen. So there are many GitHub clients. For our purposes, we'll be using GitHub this semester, but there are many more as well. So I'm going to go over the common Git commands. So just like how Victor had commands like like rm, ls, cd, the same apply for Git. So you just type Git and then the command. So these are the first few commands that you use just to start connecting to the cloud. So if you want to initialize a directory or a folder to a Git repo, you just type Git init. And say you have a project that's on GitHub, and you want to add this repo to your GitHub, you can just do git remote add origin and a URL, and all GitHub projects have a URL that it tells you. So you can just copy and paste that URL into here, and then all your files that are on your local directory will appear on GitHub. And say you want to clone a repository, so say this is what you guys would mainly be doing, because your PM will make you the repository. So on your computer, you can just type in git clone along with the URL, and all the files from that repo will appear on your computer in the current directory that you're in. And so now if you want to update the repository, here are a few commands that you can do. So git add will, if you add a period at the end, that adds everything that you're working on, or you can add specific files that you want. And then you can git commit with -m, the message. So once you're done working on a feature, you can do git commit -m, feature 1 works, or few bugs, if there are few bugs to fix, or anything that this is a message that goes along with your commit. And then after that, you can do git push origin master, which will push it to the cloud. And then if you want to update your current repository, if say your teammate made a few changes to the master branch, and you want to get those changes, you can just do git pull, and all of the changes will come onto your computer. And so this is really important. Branches are really important for Git workflow, and I'll talk about it later on the next slide. But to make a new branch, you do git checkout -b along with the branch name. So this could just be your name or feature 1 or something like that. And then if you want to switch to a new branch, you can do git branch and then along with the branch name. So this is the overall version control flow. So you have your working directory, your staging area, your local repo, and the remote repo. So your working directory is like what you're working on currently in your on your computer. So say I add a file, say like python.py or something. I can add that to my staging area, and I can add many files to my staging area. So I can add a bunch of files or a folder, or so a bunch of things like that. And then once I'm ready to make a commit, I can do git commit -m and whatever, that's some message, and that adds it to a local repo. And then after that, you can push that, and that becomes a commit, and you can push that to your branch, and that goes onto the cloud. And then the same thing coming backwards. If I want to get something that's on the cloud, I do git pull, and then that comes to a local repo, and I can check out a certain branch and start working on it in my working directory. And so the important thing about branches is on all GitHub repositories, or all repositories have a master branch. And this branch is something that you don't want to get messed up, and it needs to be functioning the entire time. You don't want any bugs on it. So if you want to work on something else, you make a branch. So this it branches off from the master branch. And then there you can start working, and you can work on your new feature throughout the course of the week. And then when you have your meetings with your PM, you can make something called a pull request. And a pull request is comparing your branch to the master branch and checking if there are any bugs that need to be fixed or any conflicts. And you'll usually do this at your code review or your weekly meeting with your PM, you guys will talk over your code, and if it doesn't conflict and everything looks fine, you can then merge that into the master branch, and now your code is also on the repository. So along with this, I'm gonna do a little demo. And so since you guys are proficient in Git now, in Bash, you can load this up. Let me make this bigger for you guys. It's huge. So you can, I've made a small project on GitHub called CS196 Git tutorial, and you can follow this link. Is that too small? Or yeah, let's go through. So it's github.com/1/CS196 Git tutorial. And so right now, all I have on this is a README, but hopefully by the end of this demo, you guys can commit some things to this repository. So let me know when you guys are have this and ready to go. And so if you guys are using Windows, you can use Git Bash, Git Bash for Windows. And I think on Mac and Linux, Git install. If not, you can just install it. Alright, so I'll go ahead and get started. So I talked about Git clone, which is getting the cloning repository onto your onto your own computer. So for that, you can just do git clone, and then every repository has a URL, which is right here. So you can just copy and paste this here, and that clones it. Actually, I'm going to clone this onto my desktop so it's easy for you guys to see. So I'm going to CD into my desktop, and then do the same thing. So as you can see, it shows up right here on my desktop. It's cool. So now I can CD into my repository. Right now, all it has is a README. So if you guys are following along, now you can, if you want to start making changes to this, you have to check out a new branch. So you can do git checkout -b, and you can name it like your own name. So I'll do Shreyas. So now I'm on a new branch called Shreyas. You can just do git branch to check which branch you're on. And it says I'm on Shreyas, not on the master branch. Yeah?
Why do you use the checkout?
Alright, so checkout is to make a new branch. So when I was talking about the slides here, checkout is basically going from the master branch, I'm checking out a new branch right here. And that's called Shreyas.
So you're creating a new branch?
Yeah, it's called creating a new branch. So now I'm on my new branch. So I want to make a new file, say like hello world.py. And I can just edit this file. This is really tiny, but yeah, so you guys can do whatever. If you guys are following along, you can make a different file, and you can submit a PR, or I'll get into that later. But yeah, you can just type something here. Save that, exit out of that. And so now I can git add hello world.py, and at any time you can do git status, and that'll tell you what's happening. So right now it says I have a new file called hello world.py. And so after this you can do git commit and then -m. I'm gonna say new file, and that commits the thing, and then now I can just do git push. Now it's gonna give me this error when I do git push because the default origin is not set. So all you have to do is just copy and paste this into your command line, and it'll push. And then as you can see right here, it says there's a new branch called Shreyas, just less than a minute ago. So to open a PR, which is what you'll do every meeting, you can just do compare and pull request. And so the new file is the message I put in my commit. And so I can just leave a comment like, please review my code or something. And you can also do what, you can assign certain people to look at it, and there are much more other features that GitHub has. But then once you create the pull request, it starts, and then you can look at the commits in the pull request. So I made a new file, and then you can look at the files changed. So in hello-world.py, I added this. And you can like review changes, like you can leave a comment, stuff like that. And that's more for your PM to do. They can leave comments on your code, let you know what you did right or wrong. And then, so if you want, you can go to pull request, and once everything is okay, you can open up this pull request. And once your PM says it's okay, you can merge the pull request, and you can add a message if you want to confirm the merge. And now it's merged, so if I go back to my code, I have hello-world.py. So if you guys want to, you guys can make a new branch. I think somebody made a new branch. My new branch. Is there someone who is following along? Or, all right. Let's just do. Oh, actually, this is what I did. Actually, never mind. Okay. So yeah. As more people commit, you'll have lots of branches. So you'll have a branch from like maybe each of your teammates will have a branch, and you can check out their branch and see what they're working on. Then you can review the code, and yeah, everyone can collaborate together and push things to GitHub. So yeah, that's basically a crash course. Of course, Git has a lot more functionality. You can like revert to previous commits and things like that. You can look up Git commands online. But yeah, that's just a basic intro, and mostly the workflow you'll be using with your groups this semester.
Okay, so that's the end of lecture. Thank you guys for staying. It was kind of a long lecture today. So basically, because you guys stayed and a lot of people left, we're going to give you extra credit. So if you go on Relate, there should be an activity called, I think it's called L3 Survivor or something. So if you click on that and you answer the question, basically you'll get like a point of extra credit or something. So yeah. So basically, we'll see you here again next week at the same time. And then you guys should have started on your projects by then, so yeah. Alright, see you next week. Also come up to me if you have any questions.